worth inhabiting, and today is not the only time worth building for.
Here begins the story. On a planet of extremes, in air too thin to breathe, where water hides beneath the dust, and yet we design life.
We are Team the Martian Future!
A crossroad of ideas between logic and imaginations, physics and philosophy.
Our project is called From a Red Dust to a Living Habitat, a self-sustained Martian habitat designed powered not just by machines, but by the principles of science, loops of nature, and human dreams.
Background. Mars has no ozone layers, no oceans, and no second chances, unless we build one.
The temperature is negative 60 degrees Celsius. The atmosphere is only 0.6% of Earth, but under its frozen regolith lies ice, and where there's ice, there's life.
How do you survive on a planet with no air, no water, and no natural resources?
The answer not lies only in technology, but in how science and mathematics whisper one solution to another. This is the science principle.
Using the principles of heat conduction and sublimation, we heat the regolith using solar thermal energy until the ice settles, a proximity of 0 degrees Celsius under the Martian pressure.
The second is called a closed ecology loop. Our system functions as a closed ecological loop. It's like a miniature biosphere, O2 and CO2 cycles. We are going to continue to the next one, and that is the science principles. Photosynthetic biology. In a closed system, they are going to absorb CO2 and produce oxygen, also known as O2, in the process. 6 CO2 plus 6 H2O, also known as water, plus light H12O6, also known as glucose, plus 6O2. In this project, science is not just a support, it is the beating heart. Physics moves energy, biology creates breath, and chemistry makes alien soil to life.
This is the mathematical principles. The first one is electric energy for life. To operate a habitat for 100 people, the average electricity needed is 3.5 kilowatt hours per day. The energy total Thus, 2 turbines are needed to ensure supply during unstable weather. The second, energy for heating regolith. The third one, food energy from aquaponics. The fourth, waste and nutritional compositions of regolith. Waste is converted into compost until we have regolith fertilizers. Greywater is recycled using UV stabilizers and biofilters. This is the mathematics of life. A habitat is not just a structure. It's the numbers behind food, oxygen, and sustainability.
Part of the Mars Habitat Prototype. Energy system. The miniature wind turbine represents Mars' primary wind-based energy. Solar panels are placed to absorb Mars' dim sunlight, still sufficient with efficient design. The combination shows a hybrid energy system, electricity and thermal.
The solar panels follow the sunlight using AI sensors.
And then there is a power storage in case of an emergency.
Regolith heater and water extraction. A simulated regolith heating chamber turning subsurface Martian ice into steam then condensed into water. This part illustrates an artificial water cycle supporting daily needs.
Plant ecosystem and food production. Vertical hydroponic modules provide fresh vegetables. Aquaponic system is shown with small fish tanks for protein and organic fertilizer. Row crop farming area shows Martian agriculture with enhanced compost soil.
Water and waste circulation. Symbolic flow channels show recycled water and biofilter system. Organic waste from inhabitants is processed into compost for farming.
Radiation protector underground. The underground section acts as like a safe zone from cosmic radiation and extreme temperatures. It functions as a sleeping quarters, storage, and a lab area.
Control center and oxygen circulation. Control center is for monitoring temperatures, pressure, and oxygen levels. Phytoplankton photosynthesis chambers is shown via small transparent tanks for oxygen production.
This prototype may not breathe, but it speaks of systems, of interconnections of the future.
Thank you, dear judges, because today you're not just scoring ideas, you are witnessing the future.